So as far as the squared function is concerned, what we have is we are actually, if you've been given as f of x, x maps on f of x, and you are supposed to sketch now the mapping of x onto f of x the whole square. This is actually called squared functions, like newly included for AHL syllabus. So this used to be assessed earlier, but not like in explicit form. This is just like a logical transformation. So what we do is that if I have got, let's say, table of x and y values, x and y, what we do is you actually square the y value. So you square the y value and you plot against the same x value. So for example, you've got x is 1, y is 2. Now it'll be like 1 comma 4. So earlier you plotted 1 comma 2, now I'll plot 1 comma 4. If I like x is 1, y is negative 4. If I plot now, it'll be 16. If I have got x is, let's say, 2, negative 2, let's say, for example, and y is, let's say, 0, the value of 0 square is 0. And if I've got x is negative 3 and y is 1, the square of 1 is 1 itself. So when you actually try to sketch the squared function, what you do is you actually like take the exact values and square them, take the y values and square them and plot against the same x value. That's what is the logic. So what actually we draw some conclusions from the first data set that I've shown here is that number one is the roots remain the roots. So the root at any point, if you see that y value is 0, that point is not going to change. So that's an invariant point. If the function is at 1, its a square function is also 1. So that also is not changing. So any y values that is along 1 or 0 doesn't change. Any negative value gets squared, and if it is higher than 1, you can see that it becomes further bigger. But if you got, like, for example, if it's 0.5 or something, negative 0.5 for, let's say, negative 4. So if you square this, it becomes 0.25. So numerically, this is going to come closer to the x-axis. So what we'll do is just take an example first for this part. So let's say this is x and y axis. And now what I'm going to do next is that I'm just going to show you a simple quadratic. Let's say here, I'll just take quadratic. So the quadratic graph is, let's say, something like this. Now what I'm going to do is I'm just going to draw the squared function for this. So this point is 4, positive 4. This is, let's say, negative 3, and this is positive 2. So what I have to do is draw a squared function for this. Now, first thing is that if you look at the roots are remaining the same. So this point and this point is going to remain the same. And what I'm going to do next is basically, I'm just going to simply take the y equals to 1 function as well. So when you take y equals to 1 function, basically, now in this case, it is, let's say, y equals to 1 is here. So this point actually is the invariant point. So this point is also not going to change. These values which are negative will be also becoming positive. So firstly, when you have negative values becoming positive, now, for example, this is -4, it will become somewhere at the same point here, become 16. So something like this. Now, what happened is that if you're drawing the graph of this, the first part is that you make negative values positive. The general shape is not actually too much of concern. It can be little, like, deeper here, or like it's up to you, but just make sure that understand that if this is y value here, which is between 0 and 1, the square of that value will move further smaller, become smaller. So it'll move closer to the x-axis. That's what is the example here. For example, it's negative 0.5 is, let's say, here. If you square that, it is positive 0.25. So that's slight a bit lower than this point along the y-axis. So whenever it is this case, you just make sure that the curve is below, and then after this, it shoots up and it contains 16, let's say here somewhere, and then comes back from this point, and it won't go like this. So it has, because these y values are between 0 and 1, so square of them will be smaller. So as per inequality, it has to be below. And this side, obviously, it is going to go up again, because negative values are going to get squared. So this is the basic square function. Just logic here is that you any value that is between y between 0 and 1, let's say this is 0 and this is 1. So in this case, if your original function is like this, the squared function will be something here. If the function is having any negative values, that moves up, because the squared function does not have any of the negative values left then. Okay, so let's, if you want to draw the squared function for this one here. So now you got here, let's say at x equals to 2, there is a vertical asymptote for the original function. Y equals to, let's say 3 is this point. Y equals to, let's say 2 is this as well. Now, when you're drawing the horizontal asymptotes for the squared function or the roots, the first thing what we do is the vertical asymptote doesn't change. So where the function is undefined, like for example, if you have x is, let's say 5 or something, y is undefined, the square function is also be undefined. So number one is that this point doesn't change. Number two is that if you have got horizontal asymptote at y equals to a, now the new horizontal asymptote becomes y equals to a squared. So y equals to a squared function, you're going to just draw. Now, for example, you got y is 2 here. So the new horizontal asymptote is actually going to be at y equals to 4. So this is going to be the new horizontal asymptote. So this y equals to 4. This root point actually remains the same. So the root doesn't change actually. So the root point is going to be the same as it is. So I'll just draw in purple lines the specific requirements for this one. So these are the dimensions that I'm drawing for the square function. Now the next step is that how do we deal with this part here? So this part obviously gets squared and become positive. It'll be little lesser steeper here. You can see these y values that I'm taking little closer to the x-axis, and then it shoots up. So it goes up and it can cross the horizontal asymptote. That's okay. That's this part. I'll just come to that in a bit. Now here is that y equals to 2. You can see the y values are positive. So the squared value will be above 4 line. So this is the new part of the graph here. Now the next part is this part. How do we draw? Is that this side, you can see that this slight a bit positive. So it'll come closer to the x-axis. After 1, suppose this is y is 1, it goes up. And then if this side, it is going to be below 4, because you can see that this never crossed y equals to 2. So this side is going to be below 4. So this is how you actually analyze and sketch the graphs of the squared function when there is a horizontal asymptote or vertical asymptote involved.